capai misi yang satu, permisi kita bantu.
Tahniah, siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hi, Salam, Sejahtera dan good evening everyone. Welcome to Pusat Tuisyen Akademi Youtuber with the joint venture of EDD Malaysia and Jadual Malaysia. Bermula percuma, selamanya percuma. I'm Mr. Peh. Currently, I'm teaching at College Tingkatan 6 Tun Fatihah Melaka. I am the on-duty teacher for this week. For your information, Akademi Youtuber preparing 2 physics classes for you, which is Form 4 class and will be always here on every Friday, 9:30 p.m. And we are actually at Chapter 3 already. While another lesson, there will be Form 5 Physics will be here on Sunday, like today, 8:45 p.m. Okay, so for today's lesson, there will be take about 1 hour to be complete. And the link ECG will be provided at the end of the lesson. So please fill up the detail within 30 minutes just after the live session finish. And all the email is available, can be used to fill out the link ECG and will be provided at the end of the lesson. So without further ado, okay, so let us start our lesson today. So as mentioned, for Form 5 class, we are actually now at Chapter 3, Electricity. And the subtopic we are going to learn today, there will be subtopic number 2, resistance. And for today's lesson, you are going to learn about the 6 learning standard. So hopefully the lesson can be finished within 1 hour. You may actually ask the question. If I say you got any problem you see in my slide in the chat room. Okay, so let us start our lesson now. Okay, so for the first learning standard, you have to compare and contrast the ohmic and non-ohmic conductor. Okay, so what is the ohmic conductor and non-ohmic conductor? And what is the difference between them? Okay, so at Form 3 and Form 2, you actually learn already the concept of Ohm's law. Okay, so the relationship between the current I and potential difference V between 2 points is given by Ohm's law. So the relationship between the V and I, you can actually relate them with Ohm's law. Okay, so the conductor that obey Ohm's law be known as the ohmic conductor. Then for the conductor that do not obey the Ohm's law, we call it as non-ohmic conductor. Okay, so according to Ohm's law you learned previously, okay, so the electric current flow through a conductor is directly proportional to the potential difference across it if the temperature and the physical condition are constant. Okay, so here can referring to length, diameter of the wire and others now. Okay, so here from the Ohm's law, V over I is constant. Okay, so you can just observe the graph here. You can see that when you draw the graph V against I, you may see a straight line passing through the origin. So it will be 0, 0 here. Okay, so if I say the conductor showing the result where showing in this straight line passing through the graph V against I, or we can know as V is directly proportional to I. So the conductor is said to be obey the Ohm's law and known as ohmic conductor. Okay, so from the graph, the gradients showing the difference of voltage over difference of I. So it is actually represent as the resistance. Okay. So the resistance R of the conductor is defined as the ratio of the potential difference across the conductor to the current flowing through it. So there will be V against I lah. Okay, so the ratio here will be ratio of V to I. So the gradients of the graph V against I is actually represent the value of resistance of the conductor. Okay, so in the line here, we have Jimmy. Okay, so thank you, Jimmy, for joining my lesson. So please stay together with me here. And if you have any question, you may ask me at the chat room. Okay, then the next will be the unit for resistance. Okay, so if I say you look at the graph, so V will be with the unit of volt, and then the I will be ampere. So there will be V per A. So here we can use the ohms unit to instead of V per A here. Okay. Okay, so the relationship between the current and the voltage, or here potential difference, can be carried out by experiment. Okay, so that means that here we can using the example of the ohmic conductor. Here will be constant wire, and non-ohmic conductor. Here we're using filament to show the difference between the ohmic and non-ohmic conductor. Okay. Okay, so let us go through the experiment together. Okay, so the experiment you'll be see a detail at your textbook, page 100 to 102. Okay, so the experiment will be like this. You can refer to your textbook. Okay, so here the aim is actually to study the relationship between the current and the potential difference on ohmic and non-ohmic conductor. Okay, so this will be the aim. So as mentioned just now, the ohmic conductor will be using the constant wire. So be at here, the A experiment. And then the bulb, where the material usually will be tungsten. Okay. Okay, so so the variable for this experiment, they will be first manipulator will be current, then responding will be potential difference. Constant, there will be temperature, diameter, and length of the constant wire. So where we explained just now, the physical properties for others must be constant. Okay, so here referring to this temperature, diameter, and length. And then the setup will be as the figure 3.12 here. Okay, and then here the current will be started with 0.2. If I say you can just look at the result table here, and also others value. So minimum normally will be take about 5 reading. Okay, and then we will read the reading for voltmeter for respective value of current here. Okay, so as mentioned, the aim will be we want to see difference between the ohmic and non-ohmic conductor. Okay, so the first will be using ohmic conductor, and then we expected the graph will be straight line. For graph V against I or I against V here. Okay, and then the secondly, they will be using filament bulb as mentioned just now for instead of the constant wire in this figure 3.12. Again, we will be using different set of the data here. So here we have 0.14 current ampere of the current until 0.22 ampere. Let's say you're following the table 3.3 in your textbook. Okay, and the graph will be expected not the straight line. Here just as mentioned, so we're using filament bulb instead of the constant wire for the experiment B here. Okay, so the graph will be expected a curve and not obey the Ohm's law, where it will be actually showing a straight line passing through the origin for the graph V against I or I against V here. Okay, so the stimulation, you can actually follow my few of the YouTube class. Okay, so you can just referring to these two link so that you can look at the detail for the stimulation for this experiment, together also the paper 3 for the question related to this experiment. Okay, so the differences of the ohmic conductor and non-ohmic conductor can be observed after we go through the experiment 3.1 just like I mentioned to you. Okay, so here firstly, we can compare the graph V against I for ohmic and non-ohmic conductor. Okay, so for the ohmic conductor, as mentioned, where the conductor will be obey the Ohm's law, so where it will be showing a straight line passing through the origin. So it will be like this graph. Okay, V against I, or I against V, actually you'll be get the straight line also lah. Okay, so the graph showing that for ohmic conductor, they will be obey the Ohm's law, where V over I will be always constant. Okay. Then for the non-ohmic conductor, a curved graph passing through origin will be formed. Okay, so here you can see this will be not obey the Ohm's law, as the V against I here is not equal to constant. Okay, it's a curve. Okay, so secondly, you can see the relationship between V and I here. So for the ohmic conductor, the V will be direct proportional to I, while for the non-ohmic conductor, the V will be increases with I. Okay, then the rate of increase of potential difference, so will be always constant for ohmic conductor, and then for non-ohmic conductor, they will be increased. Okay, and then the last will be the resistance. So when represented by the gradients of the graph. Okay, gradients of the graph, I say V against I. So the gradients represent the gradients. Okay, so the gradient represent the resistance. If the graph is I against V, so the gradients will be represent 1 over R. Okay, so this will be different for the graph V against I and I against V. So you can see the detail at the video link I showed you just now, and later on I'll put in the description. Okay, so the constant will be for ohmic conductor, and then the non-ohmic conductor, there will be increases now. So this will be the difference you may observe through the graph of ohmic conductor and non-ohmic conductor. Okay, so the next year we go for our second learning standard. So where we want to solve the problem involving the combination of series and parallel circuit. Okay, so against here, I want to show you the characteristic of series and parallel circuit. Okay, and this actually you also learn through Form 3 and Form 2 also. Okay, electricity. Okay, so for the first figure here showing the series circuits, where you can see the resistor R1, R2 and R3 is connected end to end. Okay, so this will be series circuit, and the formula related to this will be, you can see the I, so where the total I showing at the reading of ammeter will be same as I1, which is showing at A1, A2 and A3. So all of the current will be have same value, as the current is flowing in one path only. Okay, then for the parallel circuit, Okay, so the I where showing at the reading of ammeter A here, there will be the total current flowing at the different route here. So you can see the R1, R2, and R3. So they are arranged in separate path. Okay, so the A1 will be the current flow through the R1. Then A2 will be current flow through the resistor 2. Then R3 will be the current flow through the R3. So the total R1 plus R2 plus R3 will be I, which is the reading of ammeter A here. Okay, so secondly, we compare the voltage. Okay, so the voltage at the V voltmeter here will be V1 plus V2 plus V3. Okay, and then the case of parallel circuit, so the V at the voltmeter V in the figure here will be same as V1, V2, and V3. Okay, then the next here, okay, so here I have see another student join me here. They will be Ewan. Okay, Ewan. So welcome to join my lesson. Okay, so hopefully you gain some knowledge through my lesson today. Okay, then the next will be the effective resistance. So the effective resistance here, the R will be equal to R1, R2, and R3. For the parallel circuit, so the effective resistance, they will be using this formula. 1 over R equal to 1 over R1 plus 1 over R2 and 1 over R3. So basically, there will be the different formula you are going to apply with different circuit here. And here, the question will be related to combination of both series. Okay, so let us try the checkpoint question number 1. Okay, so here, find the effective resistance. Okay, so here we're going to find the value out here. Okay, so you may show your answer at the chat room. Okay, so for the first question is actually very easy. Okay, so here, firstly, you have to identify which circuit is for the question A. Okay, so the question A is a series circuit. Or you can see all the resistance is connected end to end. So there will be 20, 10, and 5. Okay, so very easy. You just add on all the resistor. 20 plus 10 plus 5. So you may get 35. So remember, give a unit for your answer. Without the unit, the value correct also will be deduction for your marks. Okay, then the second will be very clear that this will be the parallel circuit. Okay, so here we have 3 circuits. So for the effective resistance for the resistor connected in parallel, you're using 1 over R equal to 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so this will be the step how we do for this question. So 1 over R plus 1 over 5 plus 1 over 10. So we equalize the bottom parts of fraction here. Here will be times 5. So 5 plus 2 plus 1, we get 8 over 10. So 1 over R equal to 8 over 10. So we have to reverse R equal to 10 over 8. So your answer must be given in decimal place. Okay, so change the answer and you get 1.25 ohms. Okay, so this will be considered quite easy, right? Okay, so the next question C will be harder. So here we have the combination of the series. So here will be series and here will be parallel. Okay, so here which part you have to solve first? So you actually need to solve the parallel circuit first. So where will be showing by these 2 resistors. Okay, so you can see we're using 1 over Rp equal to 1 over R plus 1 over R. So here we get 2 over R. So 1 over Rp equal to 2 over 8. Therefore, 1 over R is 3. Therefore, 1 over R change to RP will be 8/2, which will be 4 ohms. Okay, and then, so that means here they will be changed to become 3 resistor. Here will be 10, here will be 20, here will be 4 ohms will be changed to this already. Okay, so the effective resistance for C here, series will be 10 plus 20 plus 4. So we get 34 ohms. Okay, so this will be the answer for this question. Okay, okay, and then the next here, there will be series, and here will be parallel. Okay, so again, here we have to solve the parallel first for this question. Okay, so again, 1 over RP equal to 1/4 plus 1/2. Okay, so you just equalize the upper parts for the fraction, so you get 3/4. Therefore, your RP will be 4/3. Right? 1/4 plus 1/2. So we get 3/4. Okay, then here there will be 4/3 for RP. So the total resistor, so now here will be changed to 1 ohms and 4/3 ohms. Okay, so 1 plus 4/3, so we will get 7/3 ohms. Okay, so you have to change to decimal place. So let me show you the answer I already typed nicely. Okay, so this will be 34 as I mentioned just now, right? Okay, so this will be the second. Just now I show you the first parallel parts, they will be 4/3. So you have to change to decimal place. You can left your question, left your answer in fraction first, then end with decimal place. So after that, you have to add both together. So you get 2.33 ohms. Okay, so after the practice, how we calculate the effective resistance for different circuit here. Okay, so now we practice another question where will be the example question for paper 2 section A related to the learning standard 1 and 2 here. Okay, so here the question will be like this. Okay, so diagram 14.1 shows the circuit used to investigate the relationship between current and potential different across the constant wire. So when you see constant wire, so you know already, so this is a ohmic conductor. So it will be showing a straight line passing through the origin. Okay, you can just using the Ohm's law to calculate the related value we want. Okay, so here name the apparatus label in X and Y. Okay, so here you can see the apparatus X here is connected in series in this circuit. For the measurement, here will be ammeter. So we know already the ammeter will be connected in series, and then Y here we measure the voltage, okay, potential difference by using the voltmeter where need to be connected parallelly for the circuit. Okay, so here X will be ammeter, very clear. Then Y, they will be voltmeter. Okay, then the next question, there will be, what is the relationship between the reading of the measuring instrument X and Y? So relationship. So here is very clear that, just like I mentioned to you, the constant wire is an ohmic conductor. So the V will be what you will get for Y instrument, and then X will be I. So I will be directly proportional to V. So where the tips here, just like I mentioned to you, first you need to know the constant wire is an ohmic conductor, where it will be obey the Ohm's law. So the relationship will be directly proportional. Okay. Okay, then the next question here will be the physics law involved in B1. Okay, so here, since I mentioned to you, so the conductor is Ohmic conductor, so the law here will be Ohm's law lah. Oh, it's not very hard actually. Okay, so the next question, C. Okay, so here will be the calculation. So where involving the combination of the series and the parallel circuit. Okay, so the first question will be asking you to calculate the resistance of the circuit. Okay, so here, this is parts where series, and here will be part where is parallel. For both 10 ohms resistor here. Okay, so here we have to using 1 over R to get the first two resistance reading. Okay, so here we get 2 over 10, so it will be 1 over 5. So the parallel parts will be 5 ohms. So, and then the total resistance or the effective resistance here, they will be 5 plus 1, they will be 6 ohm lah. Okay. Okay, so let's see the proper answer I already prepared for you. Okay, 1 over R, here will be the parallel parts, will be here. So we'll get equal to 2 over 10. So end out there will be 5 for the parallel here. So the total or effective resistance here will be 5 plus 1, there will be 6. So the first mark will be substitution. Second mark will be answer with correct unit. Okay, then the next. Okay, so what is the reading of the ammeter? Okay, so here the question provides us the voltage. Overall voltage, it will be 12 volt. And then the effectiveness resistance we already get from question number 1, which is will be 6. And here we will be using the Ohm's law. V equal to IR. So I will be V over R. Okay, so here V 12, and then the R we get 6. So the step will be like this. 12 over 6. And then we get 2 ampere. So make sure you give the unit for the answer. Okay, then the next here, there will be the question like this. Okay, so one of the 10 ohms resistor is removed. So that means here is no more from the circuit. So what will happen to the readings of the ammeter? So it is increase, decrease, or remain the same. Okay, so here, so what will be occur if the 10 ohms resistor is removed already? One of that. So that means you can see parallel circuit now is no more. And now they will be only in series. Okay, so if let's say you can just calculate the effective resistance in the current circuit here, so there will be 1 plus 10. So you can see there will be 11 ohms. So you compare the answer from number 1, which is 6 ohm. So you may see that the resistance value is increases already. So when resistance value increases, so the current flow, there will be decreases lah, right? Okay, because resistance is a part, is a component that reduce the current flow. Okay, so here the ammeter reading, there will be very clear that there will be decreases lah. Or you can using V equal to IR, I equal to V over R. So you can see with the value of voltmeter voltage here maintain the 12, with the value of R increases from 6 to 11, so the current flow will be decreases. So we are very clear that the voltmeter reading will be decreases lah. And you actually can calculate the answer. So the current flow now, there will be 12 over 11 lah. Okay, so you have to change to the decimal place for your final answer. If I see the question asking about this. Okay, so the next here we go for our third learning standard. Okay, so we have about total 6 learning standard we are going to learn today. Okay, so for the learning standard 3, you have to define the resistivity of the wire. So what is the resistivity? And then the second, describe the factor that affects the resistance of the wire through the experiment to conclude the formula R equal to rho L over A. Okay, so what is that? Okay, so from here you can see the resistance value is affected by these 3 parameters. Okay, and you will be able to show the relationship through the experiment. So the experiment is very important for you to understand so that you have the idea to answering the question of paper 3. Okay. Okay, so for the first, we need to define the resistivity of the conductor. Okay, so what is the meanings of resistivity? So the definition of the science term or physics term may ask for the first question, especially at section B and C. Okay, so the resistivity of the conductor we using the symbol rho is similar to density, right? Okay, so it's actually a measure of conductor to oppose the flow of the electron. So it's quite similar to resistance. So where is actually prevent or slow down the flow of the electron. So that means here the electric flow will be also decreases. Okay, so the resistivity is actually measurement for the conductor, for the resistance, and the conductor length is 1 meter. Will be this. So resistivity of conductor can also define as the resistance of the 1 meter length of conductor. Okay, so that has a cross-sectional area which is also 1 meter square. Okay, so this is a definition of the resistivity where the resistance of the conductor is measured in the length which is 1 meter and the cross-sectional area is 1 meter square. Therefore, the unit for the resistivity is ohm meter. So if I say resistance, there will be ohm. So the resistivity is ohm meter due to the resistance of the conductor is measured by the length of 1 meter. Okay, so you can just think about this. Okay, so here we have the example with the same length of the material. So you can see the resistivity is different. Okay. Okay, then here the factor that affects the resistance of conductor. If I say you just go through the learning standard with me just now, according to the formula, there will be 3 factors affecting the resistance of conductor. Okay, so here let's discuss the first one. Here there will be length of the wire. Okay, so generally, so at constant temperature, so the resistance of the conductor increases when the length of the wire increases. So here we have the same type of the conductor, so with the different length. Okay, so you can see with the L, where the R we get, so the length increases may cause us the resistance value also increases. Okay, so here the graph showing that R against L here, showing a straight line passing through the origin. Okay, and this may be proved by using the experiment 3.2, which is actually the compulsory experiment. You learned already. Okay, I think you also did already with your school teacher. Okay, so here this will be the detail. So where the detail you can get from the textbook 106 to 107. Okay, so the aim is to study the relationship between the length L and the resistance of the wire. Okay. Then the inference you may write in this style method, this style format. Okay, so here length of wire, this will be the manipulated variable. Affects the resistance of the wire. This is a RV. So you can using this method to write your inference for your paper 3. Okay, so MV affects the RV. So the MV here will be the length of wire, and then the RV here, there will be the resistance of the wire. Okay, so how we get the resistance of wire? So we will be measure the current by using the ammeter, and then the V, there will be the voltmeter, and you can get the voltmeter reading. Again, we're using V equal to IR. Okay, so here we're using the constant wire, right? So we'll be using this formula. So the R will be V over I. So that means after you get the reading, V and I, you have to calculate the R so that you can get the reading of resistance. Okay, so the hypothesis, we already go through the theory. So when the wire, length of the wire increases, we expected the resistance value will be increases. Okay, so the manipulator, as mentioned, this will be the length of wire. Then the responding variable here, there will be resistance value where you can get through this formula. Okay, so the constant variable, there will be others factor. Here, diameter of wire, resistivity, and temperature. So temperatures must be always a factor affecting the resistivity. Okay, so when temperature increases, the resistance of the wire also will be increases. So we will be discussed later on. This is actually one of the factors affecting the value of R. Okay, so the apparatus, you can just go through the list here. Okay, so there will be, we have the battery, switch, ammeter, rheostat, voltmeter, constant wire, meter rule, and then the corona crate. Okay, so the procedure, okay, so this is a simple procedure you may use to write the answer expressly for the question where the procedure is not provided, and we know as the tugasan amali tidak berbantu. Okay, so the first, arrange the apparatus and draw the apparatus arrangement like this. You may get the first mark. Okay, and then you must given your first RV so that you can get your second mark. So the procedure for tugasan amali tidak berbantu normally will be about 4 marks. Okay, second, close the switch and here adjust the rheostat until the current flow is 0.5. So here we need to adjust our rheostat, okay, so that you get the reading 0.5 at your ammeter, and then you have to take your voltmeter reading. Okay, so you see, record the value of voltmeter. This will be your first, just now one, this is the first MV. So this will be first RV. Then calculate your resistance value with the formula V over I. I show you just already. Then repeated the step 1 and 4, until 4 with different length. So minimum 5 MV. Okay, so including the first one. If let's say the procedure is not given in the question of paper 3, so you have to give 5 MV unless the reading is given in the question, you just follow. Okay, so again, so the stimulation and the sample paper 3 question for this experiment you may find in this video. So now, so the link will be this, and I will be added in the description later on. Okay, so here, thank you, Cikgu Hasnitah, for joining my class. Okay, and also thank you for Jimmy again. Okay, so thank you for continue, stay with me here. Okay, so here, this will be the reference answer. Okay, so again here, as mentioned, in the step, the L will be 20, 40, 60, 80, and 100. And then as mentioned in the procedure, so the value I is fixed as 0.5. And then we will get our voltmeter reading. where will be 0.4 and others lah. And okay, and here we actually want to get the value of R through the formula I advised you just now will be V over I. So the V here is 0.4 and then the I here is 0.5. So that we get 0.8. So others reading will be also using the same method to get. So will be like this. Okay, so this is a sample result for this experiment. Okay, so first the question might ask you, okay, so ask you to plot the graph R against I. Against L, it will be this. Okay, so here this will be the graph I already plot. So make sure your x-axis and y-axis will have the symbol and unit. Okay, symbol and unit. Okay, so here this will be the first point where there will be 20 and 0.8. Okay, will be about here. Okay, and then others, second point will be this and this. So you may get a straight line passing through origin will be like this. Okay, so the detail, how we plot the graph, again, you may just watch the video I referred to you just now, because within 1 hour, I need to finish this subtopic. So the detail will be take quite long time. Okay, so there are actually 7 things you need to emphasize for plotting the graph. Okay, so please refer to the advanced video link I showed you just now. Okay, so basically you will see the straight line will be passing through the origin. Okay, so the conclusion here, there will be R is directly proportional to L, or you can mention L increases, the R will be increases. Okay, so here the answer advice will be the resistance of wire is directly proportional to the length of wire. Okay. Yeah, switch on. Is it any mistake I make for the step? Switch on. Oh, close the switch. Yeah, switch also can use now. You also can use switch on or close the switch. It's the same. Okay. Okay, so here the answer, the sample question now, here will be the precaution for this experiment. So for electric experiment, you may using this answer, and for precaution, you must give the method and the reason for your answer. Okay, so what means by this? You can see the method here, all connecting wire must be tightened. So this is the method, and reason so that current can flow well. Okay, so make sure you give method together with reason for your precaution, for your precaution. Okay, so here we have decimal place for voltmeter reading. Okay, so here we have a very good question. Okay, so the decimal place for the voltmeter reading must be according to sensitivity of your voltmeter. Okay, let's say your voltmeter is with 1 decimal place, you can give 1 decimal place. Let's say 2, you must give 2. Okay, so here how many decimal place for the certain or apparatus also show very clear in the advanced video I showed you just now. But here you must according to the expansion sensitivity of the apparatus. For example, meter rule, if I say here we have 1, 2, and here within 1, 2 we have 10 segments, so there will be 0.1. Okay, so the voltmeter also the same. Different voltmeter might be given you different decimal place because the sensitivity is different. So you must showing the smallest division, or the small division for the apparatus. Okay? Okay, now, Jimmy, hope I answer your question. Okay, then the next here, turn off the switch every time a reading is taken. Okay, so this is a method. And then so that the connecting wire does not heat up quickly. This will be the reason. Okay, so as the temperature increases, the resistance will be increases. This is why we need to ensure that temperature is always constant during the experiment. Okay, then the next here, you can give also for this. So position of the eyes must be perpendicular to reading scale of ammeter or voltmeter also, right? Okay, so to avoid the parallax error or reduce. So here we have a method and the reason. Okay, so the detail for the answering technique for paper 3, you can get more in my channel. Okay, so here the next factor affecting the resistivity, the resistance. The resistance, they will be the cross-sectional area. Okay, so here I have another students respond in chat room. Okay, Putri, hi. Okay, so welcome to join my class. Okay, so here let us continue for the second reason here. Second factor here. Okay, so the second factor here will be the cross-sectional area. Okay, so here at constant temperature, you see I always set here constant temperature as mentioned because the temperature may affecting the resistance value. So the resistance of the conductor decreases as the cross-sectional area increases. So why? You can see from this figure. So when at the A, the resistance is R. So when 2A, that means the diameter is bigger. Resistance is reduced because when the diameter increases, more electron will be able to flow through. So the resistance will be decreases or the current flow will be increases. Okay? Okay, so here the next, this will be the graph you expected to draw for your paper 3. Okay? So R against A, they will be inversely proportional, or the question might ask you to plot R against 1 over A. So the R will be directly proportional to 1 over A. So these two type of graph will be showing the same factor where you can see the happens for the experiment cross-sectional area with the resistance. Okay, so the diameter of wire is shown with the SWG unit. Okay, so what is the SWG? Okay, so this will be the standard wire gauge. Is a notation for the diameter of meter root or thickness of the metal sheet, ranking from 16 mm to 0.02 mm. So you can just observe the tools here used to measure. Okay, measure the diameter of the wire. Okay. The position of eyes perpendicular to the ruler. Okay, so here better we using the scale. Okay, because you want to look at the reading 1, 2, 3, 4, right? Okay, so better we using the scale of reading. Okay, on Jimmy, so we want to avoid the chance for the marker to deduct your marks. We using the proper terms is help for you to get the full marks. Okay, we using the scale reading is better for whatever besides of the ruler. Yes, the ruler also can use, if I say, for measuring the length. Okay, but here we want to actually get the MV and RV is voltmeter and the voltmeter and the ammeter. Okay, so the ruler will be used for the experiment where we want to using for measure of length. Okay. Okay, so here this will be the meanings of SWG. Okay, and then here the value of the SWG increases when the diameter of wire decreases. Okay, you can see 24 SWG, the diameter is actually bigger. Okay, so that means the SWG increases, diameter of wire is decreases. Okay. Okay, so here this will be the graph V against I for the different size of the wire. As mentioned, V equal to IR. So R will be V over I. So that means the gradients of the graph here showing the resistance of wire. Okay, so the fine wire, where will we have the character value SWG showing higher resistance. Okay, this will be vice versa for the thicker wire. Okay, just as I mentioned to you already. So the gradient of the graph V against I, they will be showing the resistance. Okay, so with the higher value of SWG is actually showing smaller cross-sectional area. So the resistance value expected will be higher as the electron able to flow through will be decreases. Okay, so this will be vice versa for the thicker wire, where the SWG value will be lower and bigger area given more electron to flow through. So the resistance will be lower lah. Okay. Okay, so here the experiment related for this experiment, this will be at the page 107 to 108 at your textbook. Okay, so here we're going to study the relationship between the cross-sectional area, which is A, I used the symbol just now, and then the resistance of wire, which is R. Okay, so inference. Okay, so just now I also advise you how to write the inference. Here will be the cross-sectional area affects the resistance of wire. So this is a RV, this is a MV. So you're using MV affects the RV, this format for answer the paper 3 for inference question. Okay, so the hypothesis, the cross-sectional area of wire increases, the resistance of wire decreases. Okay, then the manipulated variable here we discuss about the cross-sectional area where the SWG wire is different. Then we will get responding variable here will be R. So where get from the V and I from the reading we get. Okay, so the constant variable here will be length of wire, resistivity of wire, and temperature of wire. So here will be the list of the apparatus. So you can see here we have different thickness of the wire going to use. So here will be 5, so that we can get the 5 reading of MV and RV. Okay, so here the procedure. First, arrange the apparatus as shown in figure. So write this sentence and draw the diagram. You may get the first mark for the paper 3 where the procedure is not provided, and we call it as a tugasan amali tidak berbantu. So the first MV here is started, sorry, this is a constant variable. So the first MV here we're using 24 SWG constant wire and place at P and Q. So the length of the wire is fixed, which is using 50.0 cm here. Okay, then here close the switch, or just now Jimmy advised another answer, right, which is switch on. Switch on the switch is also can for the answer. Okay, so adjust the rheostat until the current flow is 0.1. Then you have to read your voltmeter reading so that we can get our R by using this formula I also mentioned already just now. Okay, then repeating step 1 to 4 with different thickness of wire, where showing by different SWG reading. The greater the reading of SWG, the smaller cross-sectional area. We also advised already just now. Okay, so the result will be showing this. So this will be provided. Okay, and then the diameter also will be provided. Okay, so the cross-sectional area, this you need to calculate by this formula, where is pi r squared. So r will be d over 2. So you get this value, 0.40. Okay, and then the reading of ammeter is fixed as 0.1, stated in the procedure already. Okay, so the voltmeter reading is what we want to record. Then the R I advised already just now. So we're using formula V equal to IR. So R will be V over I lah. So you get this reading. Okay, so where 0.04 divide 0.1. So you'll get 0.4 lah. Okay, so again here, the question asks you to plot out against A. So you'll be using only these two reading. Okay, so make sure your axis S and Y here must be including the minimum and maximum reading now. So here will be the reference answer. Okay, so here again need to plot out against A. So give the parameter for the respective axis and also the unit. Then the scale you use must be including the minimum and maximum reading. Okay, so the first point, this will be 0.4 and 0.4. So be here. So the next here will be 0.6 and 0.25. So 0.25 will be here. Then 0.6 will be about here. And then also others now. So must draw in the baseline. So how to plot a baseline also teach already in the advice video. Okay, so make sure your point above the line and below the line cannot be more than 1. Okay, so in this drawing, you can see, so this is on the line, these two also on the line. So here can consider is below the line and here is above the line. So 1 upper minus 1 over 0. So cannot more than 1. So this is considered as a baseline. Okay. Okay, so what is the conclusion? So this will be R inversely proportional to A. Okay, so this will be the advice answer for this experiment. Okay, so later on we have more example question and learning standard 5 and 6 are going to learn. So please stay together with me here and we can have a break before we continue. Okay, so see you soon. Hi, hello everyone, welcome back. Okay, so as mentioned just now, the factor affecting the resistance of wire we discussed already too, which is the length. Another one will be the cross-sectional area. So here will be the third one, which is the resistivity of wire. Okay, so the meanings of resistivity we also learned already. So it's a measurement regarding the resistance of wire in 1 meter. Okay, so the unit will be ohms meter. Okay, so the value of the resistivity depends on temperature and also the nature of the conductor material. Okay, so that means these two, temperature and material, will be affecting the resistivity of the wire. Okay, so here A good insulating material such as rubber has a high resistance, while for the good conducting material such as silver and copper have a low resistance. So this is a comparison between the metal with non-metal. Okay, but this graph showing the comparison between the metal. So here against the gradients showing the resistance or the resistivity of the different type of wire. So nickel showing the greater M, so we have the greater resistance. Okay, so the resistivity for the nickel will be the highest compared to others in this graph. Okay, highest will be nickel, the resistivity, and then the silver will be the lowest if we compare among these four types of the metal here. Okay, so the higher temperature of the conductor, the higher the resistance. Okay, so this one just now also highlight already. So why? This is because when the temperature is higher, so the electron or the particles of the metal can be also vibrate more vigorously and avoiding the flow of the electron. So the resistivity or the resistance of the wire increases when temperature increase. Okay, so here we discuss through the experiment 3.4 at the textbook page 109 to 110 here. Okay, so the experiment is to study the resistivity and the resistance of the wire. Okay, so the inference here, you can use it in another method here. So the resistance of wire, which is RV, depends on MV. Okay, so the MV here will be resistivity of wire. So that means here we're using different type of wire to showing the different resistivity of wire. Okay, so hypothesis, the resistivity of conductor increases, the resistance will be increases. Okay, so the variable, manipulated variable here, they will be the resistivity of wire. We're using symbol rho. And then the responding, we will be also calculate the resistance through the V and I we get in the ammeter and voltmeter. Okay, then the constant variable here, there will be length of wire and cross-sectional area. That means will be another two factor which will be affecting the resistance of wire. Okay, so this will be the apparatus list. Okay, so you can just look at the list here, which will be same as the diagram here. We have rheostat, dry cell, and others. So the connection here will be changed at PQ. Okay, PQ, firstly we're using constant wire and then we're using another wire. Okay, so the procedure, first set up apparatus as shown in figure will be this. And then adjust the length of constant wire between P and Q so that the length, okay, so the length of wire here must be fixed 30 cm. Okay, then firstly we're using constant wire. Then we adjust, we close the switch on. Then adjust the rheostat until the current flow here we fix with 0.1. Then we record our voltmeter reading. Okay, so we want to calculate the resistance by using the same formula, V over I. Okay, then repeating step 1 to 5 by using nickel wire. Okay, so here we just study for two different type of wire. Okay, so the nickel wire is actually higher resistivity compared to constant wire. If I say you just together with me with the graph I showed you just now. Okay, so here the current flow is the same, and then the potential different here is the reading we get. So the resistance we're using V against I so we get 0.6 for the first one. 0.06 against I we get 0.6 Then this will be the another reading 1.6. So here we clear that the resistivity of the wire higher, it will be showing higher resistance. Also, the conclusion, so the resistance of the nichrome wire larger than the constant wire. Here we do comparison between nichrome and the constant. Okay, so this will be three factor and the experiment related to the factor affecting the resistance, okay, resistance of the wire. Okay, so factor from the factor that affect the resistance of wire. So firstly, we study already. So the resistance increases when the length increases. Then B, we study the resistance and the cross-sectional area. So where here showing inversely proportional. Okay. And then the next year, resistance increases with the resistivity of wire. From the experiment, 3.4, then here will be 3.3, and here will be 3.2. Okay, so from here, we can conclude that the resistance of the wire is directly proportional with resistivity and length, inversely proportional to cross-sectional area. So we have this formula. Okay, later on at Learning Center 6, I will show you the problem solving related with this formula. Okay, so now we go to Learning Center 5, where will be the application of the resistivity of wire in our daily life. Okay, so the first Okay, sorry, I think just now I have a problem in my line. Okay, so now I would like to continue. I think I am stopped here, right, just now. Okay, so here will be the formula where we get through the experiment. Okay, so we go for our learning standard 3, learning standard 5. Okay, so here will be the application. Okay. Okay, so here the first application will be at the heating elements. Okay, so where the heating element is made used by makeup of nickel. Okay, so the nickel is a material where have a higher resistivity. Okay. Okay, so this will be providing higher heat energy. Okay, providing high energy. Okay, so producing heat. So that means for the application where need to produce higher heat energy, we have to choose the material where we have a higher resistivity. Okay, then the next here, they will be at the electric wiring at home. Okay, so here, that means we need to choose the material with a lower resistivity, so allowing more current to flow through. Okay, so here, electric wire at home has a lower resistivity, so it minimizes the loss of electric energy generated by current. Okay, so this will be the application for these two conductor with different resistivity in our daily life. Okay, so the next here, we want to compare the non-conductor, non-conductor, semiconductor, conductor, and superconductor. So we compare the conductivity of electric. Okay, so the first non-conductor definitely is a material that does not conduct electricity, or we know as a good insulator. Okay, then semiconductor is conduct electricity better than insulator, but not as good as a conductor. Okay, so the conductor is a material that conduct electricity. Okay, so here we have the new terms we know as a superconductor. Okay, the superconductor is a material that conduct electricity without any resistance. Okay, so for conductor, just now we compare the resistivity. So that means they still given resistance for the wire. So they may have a loss of the energy if you're using a conductor. But a superconductor, they will be considered as a zero resistance with a certain temperature we know as a critical temperature. Okay, so here we compare the resistivity. Definitely, just like we mentioned already, for non-conductor, they have a high resistance. So that means they have the highest resistivity. Then the next for semiconductor, they will be, okay, so here will be the example. For the non-conductor, we have the plastic and wood. Then for the semiconductor, the resistivity will be between a conductor and non-conductor. So we have the example, silicon and germanium. Then for conductor, they have a low resistivity, where example, we have the iron and carbon, and also most of the metal. Okay, so for the superconductor, so they have the zero resistivity when they're achieving the temperature we know as a critical temperature. So example, we have the caesium at the temperature below than 1.5 Kelvin. Okay, so application here, you can see we have the MRI. Okay, MRI. Okay, so we go for our last learning standard. Here will be learning standard 6. So here will be the problem solving involving the formula of wire resistance. So where we prove already this formula by experiment 3.1 to 3.4 by learning standard 3 and 4 we go through just now. Okay, so here, hi, we have another students here. So thank you for your response. Okay, it's Wan Ying, right? Okay, so thank you. Welcome to join my lesson. Okay, so the last learning standard is more on the question discussion. Okay, so we go for the question number 3 here. You may calculate your answer and show me at the chat room together with me here. Okay, so calculate the total resistance R for a row of copper wire with the length given 10 meter. We're using symbol L. Cross-sectional area. Okay, so here we're using symbol A. Okay, so you can see here you should know to change your mm to meter square. Okay, so this will be times 10 power negative 6. And then the resistivity, you can observe the unit resistivity. They will have a unit ohms meter. We already defined our resistivity unit at learning standard for just now. Okay, so here, hi, Zining. So thank you for joining my lesson. Okay, so you can tell me where are you come from. Okay, so here the question asks about the R. So here is very easy. We just apply the one and only formula for learning standard 5 just now we go through. So the rho will be this value. Then here L will be 10. And then the A will be this. So the most important thing here, they will be changed to the SI unit. So you get this value, 0.086 with unit ohm. So you can see ohms meter is for resistivity. And then the resistance will be ohms. Okay, then the next question here will be also applying the same formula here. Okay, so we see what's the difference here. Okay, so here the copper, a coin of a pure copper wire with a length of 500 meters. And the radius given here is 0.5 mm. So here given you R. Okay, and has a resistance value 10.8 ohms. Okay, so what is the resistivity? So we need to find the rho. Okay, just now the formula given R equal to rho L over A. So that means the rho we rearrange will be RA over L. Okay, so here L given as 500, radians given as 0.5 mm, you have to change to M, and resistance given with 10.8 ohms. Okay, so A, you have to using formula pi R squared. So you substitute everything, then you get this, where the rho will be using rearrange formula here, RA over L. Substitute everything, so you may get your answer 1.697 times 10 power negative 6. Then remember, give the correct unit resistivity, which is an ohm meter. Okay. Okay, so here the next question, here will be the last question, where is section C question, the multiplication question. So the total marks will be 20 marks. Okay, so here, look at the question together. Okay, so diagram 10.1 and 10.2 shows two electrical circuit. The ammeter readings will be here. Then the ammeter readings will be, a 3 voltmeter reading will be here with symbol V. Okay, and dry cell are identical in both diagram. Okay, so the cell numbers also the same here. Okay, so state the physical quantity measured by ammeter. So ammeter is definitely measured by using, used to measure the current. Okay, so here is very easy, right? So answer, electric current. So you may get the first mark. Okay, then B. Okay, so this will be the conception question. Okay, so this will be the conception question. Here, by using diagram 10.1 and 10.2. So here we want to compare the length of the conductor. So you can see here, this is the length of conductor. Okay, so for 10.2 is longer than 10.1, right? So you can just write as length of conductor wire 10.1 smaller than 10.2. You can using the mathematics symbol. Okay, and then the next. Okay, so the next here will be reading of ammeter. Okay, you can see ammeter here is 0, here is a maximum value. So the 10.1 is greater than 10.2. So you can see the pointer for 10.2 is more closer to 0. So the reading of ammeter here, 10.1 is greater. Okay, you can using this symbol. 10.1 is greater than 10.2. Remember to write the parameter asked by the question, and then the ammeter, then the next will be voltmeter. So the voltmeter reading, you can see showing at the same value. This should be 4, right? 1, 2, 3, 4. Both will be showing the same. Here you can see very clear current for the 10.1 is greater. Here is 1, here is 4. Okay, so here is the same. So you can using equal. Voltmeter reading is equal to 10.2. So you can get full marks for this type of question. Okay, then the next here, they will be relate the length and the resistance. Okay, so from theory, we know already, right? Or you can actually calculate. Here, if I say you get voltmeter is 4, here is 4, right? So here is 4, and here is 1. So R will be V over I, right? So 4 over 4, you get 1. This will be 4. Here this will be V equal to IR. R will be V over I. Okay, so here will be 4 over 1. Okay, so it'll be 4 ohms. 4 ohms. So we are very clear that the 10.2 have higher resistance. So that means the longer the length, the higher the resistance. This one also same as what theory we learned already just now, right? So the length of conductor increases, the resistance of conductor also increases. So this is the answer for this question. And then next will be length with the ammeter. So you can see here we just need to observe the ammeter reading. So this is shorter. So ammeter reading is higher, right? So the longer the conductor, shorter. Here is shorter. Or you want to using the longer also can, but the ammeter reading is smaller. Okay. So here the answer will be length of conductor increases, the ammeter will be decreases. Okay, so this will be the comparison question. You should get full marks for this question because you can just observe the diagram. Okay, then the next here, deduce the relationship between resistance and the current. So that means here, just now we show the reading already. Here is 1 ohm, here is 4 ohms. So then here we relate to current. So current here will be higher, resistance will be lower. Okay, so that means the resistance. So the resistance decreases, the current flow will increases or vice versa. Okay, so resistance of the conductor increases, current flow will be decreases. So that means will be for this case So greater resistance, current will be smaller. Okay, so here will be another theory. Normally it will be 3 or 4 marks. Okay, so here this is the rheostat. Okay, so how the rheostat works, you can see here, there is a coil of the conductor wire. Okay, so explain how the rheostat is used to control the current flow. So that means when the slider showing or getting longer of wire, so the resistance value will be higher. So here, firstly, you should connect the crocodile clip, okay, for the connection of rheostat at A and B. Okay, so that they're given different length. Okay, second, you can adjust your slider. Okay, your slider. Okay, so the length of the wire will be changes and give you different value of resistance. Okay, so you can see here will be the marks. resistance varies with length. So the longer the length, the higher the resistance, and the current will be lower lah. Okay, so this is how the rheostat work as controller for the resistance. And this one also showing very clear stimulation at my advice video just now. You can get the detail through the link I showed you just now, and I will be give the link again at the description later on now after the end of the live here. Okay, then we go to the last question here for today's lesson. Okay, so here this will be the modification question. Okay, so here let us go through question together first. Diagram 10.4 shows the design of the wire wiper variable resistor made by the students to control the amount of current flow through the circuit. So again, just now we also got the idea already. So we control the length of the wire so that the resistance will be able to changes. Okay. Okay, so you are required to modify the design in the diagram 10.4 so that maximum resistance is greater than 10 ohm. So that means here we want to increase the value out. Okay, according to theory just now we learned there are three factors affecting the resistance value, where we want to increase the length, we want to reduce the cross-sectional area, and we're using the material with higher resistivity. These three factors can increase the resistance of wire. Okay, so here we clear the first, just as I mentioned, since we want to increase the resistance value more than 10, we will choosing smaller cross-sectional area so that the resistance will be higher. Then the length of the wire should be longer. Then the numbers of the turn. Okay, so numbers of turn will be this. When the numbers of turn is more, that means the resistance will be also higher. So that means we want to have more turns of wire. Okay, and then the conductivity of the slider. Okay, so for sure that the slider purpose is used to conduct electric. Okay, so the slider must have a higher conductivity so that the current will be easily flow through. Okay, and then the type of wire we should choosing the wire which showing the higher resistivity. For example, just now we know already, we can using the nichrome wire. Okay. Okay, so here this will be the advice method where we actually can using a table. So you can see here the cross-sectional area I give already. You can just copy from the question. So here should be smaller so that the resistance is higher. So you will get first and second mark. Then second length of wire is actually I copy from here also. So length must be higher also, right? Must be longer also. So that the reason here will be high resistance. Okay, so it's very easy for this question. And then numbers of turn, as I described with you, must be more so that the wire will be longer, then the resistance will be higher. You can see you must give more, and then the reason, all of these is the same. Okay, you cannot just write one reason because one reason will be 1 mark. So here we have three same reasons, so you have to write 3 times here. Okay, and then the conductivity of slider, just like I mentioned to you, must be high so that the current will be able to flow through from the terminal to the coil wire here. Okay, then the last type of wire here, we should using nichrome wire, right? Because it has a high resistivity. Okay, so you can see this is a sample question where it's related to the subtopic today, 3.2 resistance. Okay, so that's all for my sharing today. I hope that the lesson today may let you gain more knowledge regarding the electricity subtopic of 3.2 resistance. Okay, so thank you everyone for staying together with me until now. Okay, so please share my lesson to your friends so that more of your friends able to get benefit from my lesson. And here I want to show you the link Okay, so the link here is e-schedule link. Okay, so I already sent to the chat room, so you may fill out with any email. Okay, so please fill out within 30 minutes after the live end today. Okay, so that you can get the schedule with peringkat kebangsaan. So hope that can benefit for your Koku marks. Okay, so please keep like and share the lesson today for your friend. So as I mentioned, can more friends able to get benefits from my lesson today. And don't forget to follow the next physics classes. So for the Form 4 class will be at every Friday 9:30 p.m. So they already at the chapter 3 already. Okay, so you may do the revision before your trial exam. And as well as the Form 5 class, they will be today's 3:30 p.m. Okay, so please fill out your link e-schedule, okay, before 30 minutes after the lesson end today. Okay, so I think that's all for my lesson today. So thank you, everyone. So please always stay together with me and also our partner of IU Physics teams. Okay, so that's all for today's. Okay, so bye-bye, everyone.